Hello and welcome to Data Engineering with Subhadip. In this deep dive session, we will unlock the secrets behind BigQuery's advanced query optimization, focusing on partition pruning and dynamic filters to make your queries faster and cheaper. Here is our agenda for today. We will start by understanding why optimization is crucial in BigQuery. Then, we will explore partition pruning, clustering, the powerful dynamic filters, and finally, learn how to analyze a query plan to see these optimizations in action. The primary challenge in any large-scale data warehouse, like BigQuery, is the full table scan. When you query massive tables without proper filtering, BigQuery has to read every single row. This leads to slow performance and, more importantly, high costs, as you are billed for the amount of data processed. Our first line of defense is partition pruning. When you partition a table, for example by date, BigQuery stores data for each date in a separate physical segment. When your query includes a filter on this partition column, BigQuery smartly skips reading all other partitions, drastically reducing the data scanned. Clustering takes optimization a step further. Within each partition, clustering sorts the data based on one or more columns. When you filter on a clustered column, BigQuery can skip reading entire blocks of data even inside the target partition, providing a more fine-grained pruning. Now for the really powerful part, dynamic filters. This happens automatically during join operations. When you join a very large fact table with a small, filtered dimension table, BigQuery is smart enough to take the filter from the small table and apply it to the large table before the join even happens. This is a game changer for performance. Here is a typical SQL query where dynamic filtering shines. We are joining a massive sales table with a small stores table. Even though the filter condition is on the stores table, BigQuery's optimizer will push this country equals India filter down to the sales table scan, preventing a full scan of billions of rows. The proof is in the query plan. On the left, a poorly optimized query reads the full 10 terabytes from the sales table. On the right, by applying partition pruning and dynamic filters, the initial read is reduced to just 50 gigabytes. This is a massive improvement in both cost and speed, and you can verify this in the Job Information tab in the BigQuery UI. To summarize, here are the key best practices. Always partition your large tables, typically by date. Use clustering for columns you filter on often. Leverage dynamic filters by placing your filters on the smaller table in a join. Always verify your optimizations by checking the query plan, and be careful not to use functions on your partition key in the where clause, as it can prevent pruning. Thank you for joining me in this deep dive into BigQuery optimization. If you found this video helpful, please like, share, and subscribe to Data Engineering with Subhadip for more content. Happy querying!